The question says that two sitar strings A and B playing the note Ga, Ga are slightly out of tune and produces beats of frequency 6 Hz. The tension in the string A is slightly reduced and the beat frequency is found to reduce to 3 Hz. If the original frequency of A is 324 Hz, what is the frequency of B? So here the case is two sitar strings A and B playing the note Ga, which is slightly out of tune. So there are two strings A and B which is out of tune and they produce beats. So let us first understand what is beats. Beats is when two sound waves differ in the frequency, then upon interference they create beat, which is given by the frequency of beat is given by the difference modulus of the difference of their frequency. So here A and B would have original frequency. Now the case is the string A has been loosened and the beat is different, and the original frequency of A is given, and we have to find out original frequency of B. Since the original beat and the reduced beat has been given, we have to find out the original frequency of B. So let us start. Now it is also mentioned that the string is loosened, that is the tension in the string A is decreased in the second case. So we know that by definition the frequency decreases when the tension in the string decreases. So this will be important later on in our question. Now let Fa be the original frequency of the string A. So Fa is given to be 324 Hz. Let us assume the Fb be the original frequency of the string B. So the initial beat frequency is 6 Hz. So it can be written in the form of this, like Fb modulus of Fb minus 324 Hz, that is the original frequency of A, is equals to 6 Hz. So thus the Fb is here. We can calculate the Fb since it is modulus. So there can be two values of Fb, that is the frequency of B, either 330 Hz or 318 Hz. Now when the tension in the string decreases, the new beat frequency is at 3 Hz. So let us assume that since the tension is decreased in string A, the new frequency of the string A is f dash A. Now the new beat would be Fb minus f dash A, that is given as 3 Hz. Now in this case again, since we know that Fb can be either 330 Hz and or 318 Hz, so there can be two values of f dash A as well. So let us assume that Fb is first 330 Hz. So let us calculate the value of Fa. Upon using the same formula, difference in the frequencies, initially it was 6 Hz, now it has been 3 Hz. So the f dash A, that is the new frequency of string A upon loosening, is 327 Hz. And in the case B, when the Fb is equals to 318 Hz, we found the value of f dash A using the same formula to be 315 Hz. So upon comparison of case 1 and 2, we find that in case 1, since the string is loosened, its frequency increases from the original frequency, that is 324 Hz. So earlier it was given that the original frequency of string A is 324 Hz, and upon loosening it is 327 Hz based on our calculation, which is practically impossible, which we can infer from our previous discussion that frequency is directly proportional. It is proportional to the tension, so it can't increase upon decrease in tension. Now in case B, we see that the frequency is decreased from 324 Hz. So this seems to be more physically plausible. So we can say that the frequency of Fb is 318 Hz, now 330 Hz. Thank you.